Hello all, welcome to another video of mine. So this video is all about microcontroller features, essential elements of microcontroller ecosystem. So this is one of the series in Introduction to Embedded System Design. So the salient features of modern microcontrollers. So this is a topic which we are going to learn. So the expected functions from a microcontroller are usually to read the digital inputs, to provide the digital outputs, to measure or to maintain a record of time, relative or absolute. Maybe the time can be relative or absolute. To measure the time between two events, to measure the duration of an event, to generate the random numbers. Expected functions from a microcontroller are to respond to asynchronous events, to measure voltage, current, and also resistance, to provide analog voltage and also to provide analog current, to store the data, to visualize the data, to visualize the information, to print the data, to control the motion. So the microcontrollers will usually be having the central processing unit CPU. So it can have either 4 bits or 8 bits or 16 bits or 32 bits or 64 bits of microprocessor. So it can be a CISC, RISC or VN or even the Harvard architecture. So this microcontroller will be having a memory. The memory can be a read-only memory or electrically erasable programmable read-only memory, flash memory. So these are for program storage. Volatile memory is nothing but the random access memory, which is a temporary storage or the data storage. So the microcontrollers usually have the digital input, digital output. Input pins will be there and output pins will be there. So when we want to communicate with other devices, with other external devices like the DC motor, stepper motor, or the servo motor, then communication interfaces are also needed. In system programming and debugging, we will be using the SPI bus or the JTAG interface. Peripherals will also be there, which makes efficiency, which increase efficiency and accuracy in the microcontroller. So the peripherals usually involve timers, counters, pulse width modulation generators, the watchdog timers with independent oscillators, analog to digital converter to convert the analog signals to digital signals, digital to analog converter, which converts the digital signals to analog signals. So this can either be explicit or implicit. 6 pins, usually the microcontrollers will be having 6 pins to maximum of 200 pin of devices. So these are the examples: AT Tiny 10, uh, TIVA TM 4C1221231, Cortex M4, and STM32F205 Cortex M3. So ARM controllers and all the microcontrollers are there here. So next one is features of modern microcontrollers. So the four features are like fully programmable pins, either input pin or the output pin. Output pins with 30 to 40 mA source sink current capacity. The input pins with weak and strong pull-up or tri-state capacity. Each pin usually offers multiple functions, one of which can be selected. Multiple functions on each pin. So this is a pin diagram of a microcontroller. MSP430G 2 cross 31, MSP430G G2 cross 53. So here 28 pins are there. So power supply is nothing but the VCC port 1 P1.0, port 1 P1.1, port 1 P1.2, P1.3, 1.4, 1.5. So these pins, these 5 pins, they comes under port 1. And here we have port 2. Port 2 with the 3 pins are there. 2.3, 2.3, 2.4, 2.5 are there. And port 1 also involves P1.6 and 1.7. Port 3 Port 3 involves 3.1 till 3.7. Port 2 involves P2.0 to P2.5. So three ports are there. We have the reset pin RST. We have the test pin XOUT, which is nothing but the output pin, XIN, which is nothing but the input pin. So this is a pin diagram again. We have digital pin PD, PD1, PD2, PD3, PD4 are there. Power supply ground we have, and we have pin numbers like PB and ABCC, which is nothing but the power supply. Reference signal we have. I hope you would have found the video to be useful. We shall continue in the next video. Until then, it's bye from Radhika.